All right, and we are back. So next up, we have Ryan, and he's coming to us from a small up-and-coming online bookseller who thinks they're going to get into infrastructure. We'll see how that goes. Only joking. AWS is the biggest cloud around, and we are very glad and privileged to have Ryan with us. He is going to be showing us how to adopt native services to complement application workloads in a self-service fashion. Take it away, Ryan.
Greetings, Ryan Niksch. I am a senior partner solutions architect with Amazon Web Services. My forte for the last few years has been focusing on application platforms, hybrid solutions, application modernization, those sort of lovely industry buzzwords. Today, really having a look at customers who are running application platforms like Tanzu Application Service on AWS, and some ideas as to how they can bring a AWS product portfolio, those native services, into the mix, and how they can use those to complement their workloads running in Tanzu Application Service. So let's jump straight into that. The last few years, I've been traveling around the globe. I've engaged with many customers running application platforms on AWS. They span various industries. And in the discussions with them, I've always challenged customers, what led you to deploy Tanzu Application Service or a similar application platform on AWS? What were the drivers behind that? And there were some interesting themes that came out of this journey. Some of them were looking for a change in scalability. They were looking for a greater ability to scale. Now, that's not to say that a customer running in an on-premises context is not able to scale. Many of the customers I spoke to were running virtualization stacks. They were able to scale, but they were only scalable to a certain degree. So they could scale to a point, but at some point in time, you hit the limitations of your on-premises infrastructure investment, and you then got into a procurement cycle. And for some customers, that was a very long-winded procurement cycle. For other customers, it triggered a situation where they did not want to further invest in that on-premises context. So transitioning onto AWS, where you can scale and have the ability to tear down and not pay for things if you're not using them, moving into that consumption-based model became very attractive. For other customers, the transition was really availability-based. It was, you had some degree of resilience, some degree of availability in your on-premises context. They obviously had, redundant storage, redundant power, but in order to get from there to what they were getting with AWS was firstly a significant effort or a significant cost investment. And for some of the customers that I engaged with, they were looking to reach customers in a very global context, and that translated to them having resilience in a very far-reaching context. And for them to do this on their own, that translates to getting into investing with multiple vendors or building up multiple data centers for themselves and then managing those. So it was preferable to move to AWS on the cloud. Then again, the elasticity side of things, the ability to spin things up, tear them down, pay for what you use through some simple API calls was a significant draw card. But out of all of the items that customers mentioned, the one that stood out the most, the one that was the most common theme, was the very rich product portfolio that AWS had. You're looking at in the region of around 200 services now, and each of these AWS-native services, whether it's a database or a caching layer or a messaging system, is essentially built from the ground up to be scalable, to run in a highly resilient, elastic fashion. And what this meant for very many customers was, I don't need to take my staff, my money, my resources, and invest that into solving these problems myself for a solution. I can simply deploy an AWS service, take advantage of all of those building blocks that come as part of that service, and then associated with my applications, have my applications consume that. And the challenge that we ran into was, if a development team was trying to do this, it sometimes is a bit of a learning curve. So what we saw was developers using an application platform, VMware's Tanzu application service as an example, in combination with many AWS services and features. These might be relational or NoSQL databases. They might be caching layers. They might be messaging and queuing systems. They might be a repertoire of AI/ML services. They might be data lake functionalities. There might be whatever. But there are many things in AWS that would complement the microservices applications that would be created by these developers as essential building blocks to the architecture. But if you look at the current self-service state, many of these teams were given access to an AWS account, and that is not to say that that is for everyone. Many companies I spoke to do not provide their development teams access directly to the AWS console. Some companies tend to control that through a IT services team or through a cloud center of excellence. And even if the developer did have access to the console itself, they would initially be presented with a very, very broad span of services. You're looking at like 200 AWS products. So which of those products is the right fit for what I'm trying to do? Which of those complement each other? What are the knobs and dials that I, as somebody standing up the service, need to sort of tinker with in order to get that up and running in a well-architected best practice fashion, and then link my application to consume it? So what we were looking for was a self-service mechanism that was a little bit more prescriptive, where there can be guidance to teams around how to do this within the bounds of safety, how to do this within the constructs of business compliance, and so on and so forth. So the first food for thought item, AWS and VMware got into bed together, and what we created was the AWS Service Broker. This is an open service broker API integration that installs into Tanzu application service. You can go to the VMware network. It is published and available through that catalog. Once installed, it allows developers from within Tanzu application service to deploy AWS services without leaving the familiarity of the Tanzu platform, and then sort of bind those back to their applications. So what we essentially have is a developer being able to create something like a relational database RDS service on AWS, or an S3 object storage bucket, by using familiar Tanzu application services commands. So something like a Cloud Foundry create service, sending a create instruction to the broker. The broker in turn invokes an infrastructure as code template or a CloudFormation template outside of the platform. This is happening in AWS within the customer account. Once that resource is up and available for consumption, the infrastructure as code template signals that back to the service broker, and the service broker takes all of the bits and bobs necessary to consume that service. So endpoints, database connection names, usernames, passwords, port numbers, anything required for that service, and stores it back inside Tanzu application service. It sort of builds it as an environment variable mapping inside VCAP services, and then the application team can bind that to their front-end application. Let's quickly have a look at this in action. So what I've done here is, just in case that the demo gods smite me, I created a bit of a recording to showcase this. So what I've done here is I have logged into a Tanzu application services platform. The broker is installed. And if I do a CF marketplace, I can see all of those services that are available via the service broker. We have added a few since I created this recording. And you can see that there are relational databases. There's caching, there's messaging, there's Route 53. What I'm going to do over here is do a Cloud Foundry create service, and I'm going to define a service, in this case, Poly, which is a text-to-speech service, and using the default sort of build-out process. Punch enter, and there you can see the instruction to create goes to the broker. Broker is invoking this as an infrastructure as code template in the background. It is building this out, and once that infrastructure as code template completes, it will signal back to the broker, and I can then bind that service to my application. While that's happening in the background, I'm going to deploy a simple sample application. So again, doing a CF push of my application. And I really like this. This is, from a developer perspective, this really enables developers to do what is important to them, and that is focusing on the applications, focusing on writing code. The Tanzu application service really abstracts a lot of the complexities of the networking side, the container creations, and allows developers to simply write code. When they push that code into the platform sort of takes that code, containerizes it for you, deals with the networking, deals with the orchestration. And what this translates to is developers getting a very heightened sense of productivity because they're focusing on what they are really good at. Likewise, operators focusing on what they're good at. So there, our application has been deployed. We can see that this has been routed through the platform. So I get a route that I can connect to. And if I copy that route and punch it into a browser, this should fail. And it's failing because the backend service that the application is expecting to consume isn't there. It's been created. I just need to now go and take the binding and link it back to that application. So there you can see CF bind service, selecting the poly service that I created through the broker, binding that back to my front end application. And once that's done, I will need to do a restage of the application, essentially go and redeploy it. Again, Tanzu application service doing some really beneficial things here, doing sort of a rolling update. It'll deploy the new application and then gradually tear down the old one. So interference to a customer consuming this app is largely minimal. Just give this a moment to build out. Once that's built out, we should get an updated URL or route to get to that application. We can pop it into a browser and see the application working and consuming that AWS Poly service that we deployed into the environment. There's a couple of things to call out here. At no point in time did a developer leave the familiarity, the interfaces, the tools that they're familiar with. They are working within the Tanzu application platform service. There is very, very minimal sort of input or understanding required from a dev team to consume these services. A lot of prescriptive guidance. There you can see the audio kicking off. I'm not playing the audio, but you get the gist of it. It's taking the text and the app is passing to this and playing that back. Jumping back to the presentation side of things, this is really good for an application team that is using Tanzu application services and you want to enable a specific application team. I then ran into customers where there was a slight deviation to the requirements. What if I needed to cater for a business where there were varied business units, and those business units, some of them were using an application platform, others were using something else. So what if I had a team, one team using Tanzu application services on AWS, and another team using completely native AWS, another team using serverless architectures, another team using things like AWS Elastic Beanstalk, and I wanted to cater this self-service prescriptive mechanism to all of these business units with their variety of tool sets. Suddenly the AWS Service Broker doesn't sort of fit the requirement anymore. So what we have in the space is another AWS product called the AWS Service Catalog. Now, the AWS Service Catalog it's a catalog. You can take products and present them via infrastructure as code, either AWS CloudFormation or via Terraform. And we have the ability to not just present these as a self-service mechanism, but also use things like constraints, control mechanisms, parameter validation, tag enforcement, and ultimately not just provide something that's prescriptive, but also something that has a degree of compliance to it. So looking at this from a very high level, we create a portfolio as an administrator. We take a product as an infrastructure as code template, load that into the portfolio. We add a ability for an end user to launch this. And that could include things such as limitations, so structuring it to what a team could or could not do. Then from a user perspective, the user can go in, see this list of products, and in a self-service fashion deploy them and then consume them in their application front ends. So what we have here is standardization, enforcement of consistency, limitations of access, a very agile sort of governance platform, tag enforcement, also taking our teams and putting them, giving them access to everything they need, but not giving them absolutely full access to things. So where a dev team didn't necessarily have access to the AWS console in itself, they could now get access to Service Catalog, get the same benefit without getting into the weeds of things. Let's go take a moment and have a look at Service Catalog in action. So what I've got here is I'm logged into a AWS console, and let's jump into the Service Catalog platform. So straight away over here, I'm logged in as an administrator. So I've created a portfolio. I've created a portfolio for a serverless team. I've also created a portfolio for a Tanzu application services team. And these portfolios are going to house my products and services. As I said, I'm logged in as an administrator. So I'm getting control sets on the left-hand side of the screen to control what those products are, which portfolios they are associated with. So if once I've created the portfolio and I've added the applications or the products, either via CloudFormation or via Terraform, into that product portfolio, right? So let's just jump into that portfolio very quickly. Inside the portfolio, you'll see all of the products. What I did here is I took the infrastructure as code templates that were used by the service broker, and I added them into this portfolio. Now, I can take an existing product, something that I'm using elsewhere in the business, and add it here, or I can upload a net new product. The products, you can see, are controlled through an owner mechanism, and they will have a constraint associated with them. So each of these products has a constraint that defines whether it launches, how it launches, so on and so forth. These constraints, if I just come in here very quickly, from a constraint perspective, when I create a constraint, I can associate that with a product. I can... Sorry, it's getting a bit of ambient noise here. I can define that constraint as a launch constraint, allowing people to either launch the product, not launch the product. I can specify templates which control what settings they're allowed to invoke. So what's the cost footprint associated with that? And then, of course, if this is a launch constraint, what are the AWS credentials? What is the role that is going to be used to cater for that launch process? All right, so let's quickly go and launch one of these services. Again, what I will do is deploy the AWS Poly service so you can get a sense of what that looks like. Right, so coming through to my list of services, going to launch the Poly service. So as you can see from an end user perspective, the console does look a little bit different. You don't have the same administrative controls. And you can see very clearly here, I am logging in as an end user. And there is a list of all of my products, whether they are relational databases, whether they are NoSQL databases. So clicking on Poly, going into launching that product, and very simply popping in a name here, app. And I think what I'll do is probably change this to a production context, production Poly. Click next. Can add tags in here. I can add in additional information. Click next, and then I can go and launch this. And what Service Catalog will, very similar to the Service Broker, use that infrastructure as code template to build this out. There you can see the actual CloudFormation template listed in the background and the service building out. If you come to the provisioned product list, there you can see the Poly platform launching. Earlier today, I launched a relational database, a MySQL environment. That took around 15, 20 minutes to provision. And what you can see happens here is all of the items needed to consume the service. So the database endpoint, the credentials, the port number are appearing here. Now, there's a subtle disconnect here. With the service broker, this information is automatically embedded into Tanzu application services stored inside VCAP services. With the service catalog, we don't have that same degree of integration. We get a better reach to more teams. We get a better control mechanism, better compliance, but you are seeing a situation where a developer would have to step outside of Tanzu application service, go to the service catalog, launch a product. Once that product has been provisioned and all of the items needed to consume it are listed here, that developer would have to go back to Tanzu application service, create an environment variable mapping, and then sort of log these systems in for consumption. So there is some work being done to try and close this gap and improve the developer experience. And as we see these services and products evolve, we will likely see those features coming into play. Just having a look if we do a refresh here. Okay, there we go. And there you can see all of the bits and bobs needed to consume that poly endpoint over there. Right. As we stated, with Service Catalog, it has a lot of benefits, especially to teams where you are catering for not just teams using application platforms. You want flexibility and consistency across the entire business. And this is very attractive to financial services customers, public sector customers, healthcare, where there are compliance and regulatory concerns, as well as enforcing the concerns of the business in itself. If you jump across to the AWS samples Git repository, you will find a AWS Service Catalog reference architecture Git repo. What you can do is just go and do a Google search for, GitHub, AWS samples, and Service Catalog, and you will find this repository. And what we've created here is not just a collection of reference architectures of various AWS products and services that you can use to kickstart your Service Catalog product portfolio. We've also created a very rich CI/CD integrated pipeline. So what we have here is we've taken AWS code commit, we've taken code pipeline and code build. These are the native AWS CI/CD services, and we've linked them to this repository. So what you can do is you can create your own catalog of services and treat them in the same way you're dealing with your applications. When you update that product, the pipeline over here detects that change, kicks off a build process, creates a pipeline, loads it into your service catalog so that you are managing the applications, the products within your service catalog through a CI/CD process that you are familiar with. I do encourage you to go and take a look at the Git repository. If you're not going to use it for the automation, at the very least, use it as a guide for how you can take some of those AWS services and bring that in. And we are adding to these services constantly. Thank you very much. It has been a pleasure chatting to you, and I hope this has given you some food for thought as to how you can take those AWS native services and bring them into the fold of your applications, whether you're looking to cater for them inside Tanzu application services itself, or whether you are using other products and services. Something to call out very quickly, please be aware that many of the VMware Tanzu products are available on the AWS marketplace, so they're already there as infrastructure as code templates. So things like Gemfire, things like Tanzu application services, things like Green Plum are available, and you can add them into your product portfolio in a very similar fashion. Join me in the Q&A session. It's in a different meeting room, and have a fantastic rest of Spring 1.
Thank you so much, Ryan. I love to hear about how we're wrapping safety tape around these cloud services and then allowing companies to create their own opinionated internal platforms that are backed by these robust cloud-based products using tools like the AWS Service Broker. So this wraps up my MC duties for the day. And actually, just in time, we just having a torrential deluge of weather here in Austin, high winds and thunder. So I'm actually expecting to lose power any second. So I hope you all enjoy the rest of the conference. And hopefully next year I will see you in person. Bye.